Welcome to this explainer. Today, we're going to build a rock-solid mathematical foundation by mastering exactly how to categorize real numbers. Look, whether you're prepping for a major grade 10 math exam or just looking to sharpen those algebra skills, knowing how to instantly distinguish between number types is absolutely essential. Let's get right into it. As our source expert, Sir CP, points out, grasping these fundamental building blocks just makes all higher-level mathematics significantly easier to navigate. It totally removes the friction when you're factoring polynomials, simplifying fractions, or working through probability. Once you internalize these four categories, you can stop guessing and start actually solving. Here's our quick agenda for today. First, even and odd numbers. Then, prime versus composite numbers. After that, comparing and exceptions. And we'll wrap up with putting it into practice. Okay, section 1, even and odd numbers, the rule of 2. We're going to kick things off with the most basic binary in math, which is classifying numbers by their relationship with the number 2. This is essentially your first major filter. So, the absolutely crucial point here is that even numbers are perfectly divisible by 2. Think of it like having a pile of items and dividing them equally between two people. If it's an even number, both people get the exact same amount and there is 0 left over. And you can see this definition in action perfectly. When you take the number 4 and divide it by 2, you get exactly 2. 8 divided by 2 is exactly 4. 20 divided by 2, exactly 10. The defining characteristic is that they leave absolutely no remainder whatsoever. Now, you know and I know that when you're taking a timed test, you don't always have the luxury to sit there and do long division. Well, the great news is you don't have to. Just look at the very last digit of the number. If that final digit is 0, 2, 4, 6, or 8, the entire thing is even. It's a lifesaver for instantly identifying massive numbers like 108. On the flip side, the exact opposite rule applies here. Odd numbers will stubbornly refuse to split perfectly in two. It really doesn't matter how large or small the number is. If you try to divide an odd number by 2, it will always leave a single unit behind. That remainder of 1 is its absolute signature. You can actually see that remainder happening in real time. Try to have 3 and you get 1 with a remainder of 1. Divide 7 by 2, you get 3, remainder 1. Trying to have 15 gives you 7 with that exact same defining remainder of 1 left over. And just like before, checking the final digit gives you a foolproof shortcut. If a massive number is sitting in front of you on a page, just check the end. If it ends in 1, 3, 5, 7, or 9, you've spotted an odd number immediately, whether that's 13, 27, or 39. Moving on to section 2, prime versus composite numbers, the factor rule. Let's see how this builds into the second major way we categorize numbers, which is by counting their factors. Divisibility by 2 was a great first test, but factoring is a totally different lens to view mathematics through. Okay, quick refresher. In mathematics, a factor is an integer that divides into another number evenly. So for a prime number, it's super exclusive. It can only be created by multiplying 1 times the number itself. That is literally it. It has exactly 2 factors, making it a pure, fundamental building block in math. Notice how every single number in this sequence possesses strictly 2 factors. No more, no less. Take the number 7, for example. The only whole numbers you can multiply together to get 7 are 1 and 7. Same goes for 11. They just can't be broken down any further. Conversely, composite numbers are the more complex structures. They're basically made up of multiple components, possessing at least 3 or more factors. You can break these down into smaller integer pieces, which is incredibly useful when you're trying to simplify fractions or algebraic equations later on. For example, let's analyze the number 12. You can make 12 by multiplying 1 and 12, 2 and 6, or 3 and 4. That gives it a total of 6 different factors, definitively placing it in the composite category. Ultimately, the whole difference between prime and composite just comes down to counting those distinct factors. All right, section 3, comparing and exceptions. Now that we have our core definitions locked in, we need to compare these groups side by side. Plus, we definitely need to highlight a couple of crucial mathematical rule breakers that love to show up on exams to test if you're really paying attention. This master matrix directly contrasts our rules. And remember, these are 2 entirely different classification systems. Divisibility by 2 strictly dictates if a number is even or odd. Meanwhile, the total factor count dictates if it's prime or composite. Any given number is going to belong to one category from the top pair and one category from the bottom pair. Let's lock in a highly important fact for your exams right now. The number 2 is the only even prime number in existence. Think about it. Because it's an even number, it divides by 2. But because its only factors are 1 and 2, it perfectly fits the prime definition. Every other even number out there has at least 3 factors. And equally important, we have the ultimate exception, the number 1. 1 is completely unique because it is neither prime nor composite. Remember our strict rules? Prime numbers need exactly 2 factors, and composite numbers need more than 2. Well, the number 1 only has a single factor, itself, so it sits in a category all on its own. Finally, Section 4, putting it into practice. Okay, it's time to actually test these direct instruction rules. Let's run through some rapid-fire classroom examples straight from Sir CP's lesson to make sure you can confidently identify these properties in the wild. Applying our very first rule, how do we classify the number 18? We're looking at divisibility by 2 here, or, we can just use our visual shortcut. Because 18 divides exactly by 2, giving us 9 with 0 remainder, it is definitively even. Or you could have just looked at that last digit, the 8, and immediately known it falls into the even category. Easy, right? Next up, let's analyze the number 19 using our factor counting rule. Take a quick second to mentally list any whole numbers that multiply together to give you 19. You probably found that your list was pretty short. Since it can only be divided evenly by 1 and itself, 19 possesses exactly 2 factors. Therefore, it is undoubtedly a prime number. I'm going to leave you with this final exercise from Sir CP's practice list to solve on your own. Use that dual lens we developed today. If you can confidently categorize 27 on both spectrums, proving its divisibility by 2 and counting its distinct factors, you've perfectly mastered today's explainer. But before we go, think about this. What about the numbers 0 or negative numbers? Do they follow these exact same rules, or do they break mathematics entirely? Keep practicing, and we'll explore that next time.